Hello everyone. So we're going to look at, I would describe it as case 4, like really 4 cases, and it's a difference of squares. A difference of squares is really a teacher's favorite because it's really easy to factor. The hard thing is you may have to spot out that it's a difference of squares. So a difference of squares is a special binomial. It is the difference of 2 perfect squares. Difference means subtraction. So a factored form of a difference of squares is the product of the conjugates. Sure, okay, so what is let's rewind the clock a bit here. If I have a binomial, a minus b, and a plus b, that is, if I have a binomial that has a in the front, and one is minus b and the other one's plus b, this is what is known as conjugates. So for instance, x minus 1, x plus 1 would be conjugates. The first term in each binomial is the same. The second term is a minus some quantity a plus some quantity a. So the two terms are called conjugates. Okay, no big deal. That's awesome. Now, conjugates are really super important. So I am just going to take a look at a plus b times a minus b. What happens if we multiply 2 conjugates? Well, we get a times a gives me a squared. And then a times negative b gives me negative ab. A times b gives me positive ab. And b times negative b gives me negative b squared. What happens is that these middle 2 terms cancel each other out. And we are just left with a squared minus b squared. So do you know how math people say 1 squared, 1 perfect square minus a second perfect square? That's right. This is known as a difference of squares. And as soon as you notice it's a difference of squares, you can just factor it using its conjugates. Where what are 2 things that multiply together to give you a squared? Well, that's a and a. B squared would be b plus b, and then you can go exactly up to the top. So really, what is a perfect square? A perfect square is where both the coefficient and the variables are squares. So a perfect square can be as follows. 4x squared. That's a perfect square. 1 is also a perfect square. Now, the reason why 4x squared is a perfect square is because it's 2x times 2x. Notice how both the coefficient is a square and the variable is to an even degree, so it's x squared. Now here, 1, because it's 1 times 1. 9x squared. Well, the coefficient is a perfect squared, and the variable is a perfect square as well. Let's get back here. Case 4. The difference of squares is a special binomial. Good. So whenever you see a binomial, maybe think difference of squares. The difference of 2 perfect squares. So it can be factored into its conjugates. So when I take a look at x squared minus 9, this is 2 perfect squares, one being subtracted from the other one. So it's a difference of squares. Now how do I factor it? I factor it using the conjugates. What 2 quantities multiply together give me x squared? That's x and x. What 2 quantities multiply together to give me 9? 3 and 3. There we have it. So, look, I have a binomial. I notice that my two terms are perfect squares. So I can just easily factor this into its conjugates. 25x squared minus 4. So what two quantities multiply together give me 25x? That's 5x and 5x. What two quantities multiply to give me 4? 2 and 2. So here, the next one, negative 49x squared minus 121. Like, you should be jumping for joy that you see 49 and 121. Wow, those are perfect squares. Indeed. So what's really great about that is that instantly you know it's a difference of squares. So what quantity multiplied to itself gives you 49x squared? That's 7x and 7x. What two quantities multiplied together give you 121? 11 and 11. There. Now notice how in each of these the algebraic term x squared was first. But here we can still factor it using a difference of squares. So 1 minus 16 squared, well, it's a difference of squares. So I'm just going to factor that into its conjugates. So what two quantities multiply together to give you 1? 1 and 1. And then I put my plus and negative sign. What two quantities multiply together to give you 16x squared? And that's it. They're factored. It's beautiful. Difference of squares. Math teachers love them.